Right, guys, our focus today is going to look at another type of functions. In this case, it's hyperbolic functions. I'm warning you, these are not totally new functions. Altogether, okay. Where does this come from? Let's say, if you've got a function f of x, and you've got another function g of x. One thing which I mentioned before, like numbers, these things you can add them. You can add g of x to f of x, and the function we get here, we call it g plus f of x. You understand what I'm saying? This becomes a new function altogether. Yeah. So like numbers, we can do that. Or even if we've got a number, let's say we've got a number lambda, a real number, we can multiply f by f of x, then we get a new function which is lambda f of x. That's what it means. Now, to get to hyperbolic functions, what we're talking about here, or what we have and we should exploit to get this function is the exponential function. Especially in this case, we're looking at the natural base e to the power of x, and also we've got the function e to the power minus x. This is all what we need to get hyperbolic functions, plus maybe general knowledge you have from maths from grade 1 up to now. That's all what we need. These are two functions, isn't it? What do you call this one? It's an exponential function base e, isn't it? What's the difference between the two functions? Yeah, but what does it mean to have a negative exponent? Sorry? Tell me, okay? If you have forgotten, identify the graph of the negative exponent and identify the graph of the positive exponent. Let's take this one. I'm drawing it in red because it describes something a bit dangerous to me. Then the other one, these functions, you say these are the graphs. I'm reminding you. So which one is negative exponent, which one is positive exponent? The red one. Why do you say it's dangerous? I say this describes more or less how our natural resources are getting depleted. What did you say the name of that function is? Decay. That's exponential decay. That's the language you must start speaking now. Altogether, these words you must use them. You must start using them. So when I say what type of function is this, you must say it's an exponential function. Whatever exponential function is an exponential growth or it's an exponential decay. So if it is decay, that is growth, obviously, isn't it? So this is exponential growth, basically. So those are the two functions we need. Those are the two functions we need. Now, how are we going to create new functions here? Because these functions can be added. Okay, we can add these two functions, e to the power of x plus e to the power minus x. You can check here. Look at this. What's the value here? What's the value of y at this point? What's the value of y at that point? 1. Now, if you add those two functions there to 1, what are you going to get? 2, isn't it? 2. So when you're saying you're adding functions like this, when you evaluate those functions, that function, it means you're going to evaluate this function and evaluate that function and then add the result, isn't it? But this is not what I want. What I actually want is the average of these two functions. What did you do to get an average between two quantities? What did you do? Divide by 2 altogether. So this is the function I'm looking for. This function has got a name. It is the average. Listen, this is what I'm trying to emphasize. I don't want somebody to look at the hyperbolic function as something new. Otherwise, if you do that, then you're wasting your memory. What we have, we've got Exponential functions, you just play around with them, you add them, you average them, you get a new function. And because that function is interesting, is important, is useful in life, so we need to focus on it, and that function is called the cosh of x. Cosh meaning cosine hyperbolic. So it's a cosine hyperbolic function. Are we together? Yeah, that's a new function. You can try to play around with this curve here, just to try to make sense how does the curve of this function look like. What does it do? Every time you pick the values of two functions, you must add them and divide by 2, isn't it? So already 1 is the value of the function. Was it to be 1 plus 1, 2 divided by 2, 1. So this function also crosses at 1. This cos hyperbolic. Then if you come here, if you add the value here, which is almost close to 0, to that one which is high, and then divide by 2, how is going to be the answer after dividing by 2? Is it going to be higher than this one, or is it going to be lower than this one? It's going to be higher. After dividing by 2, check this. You have got a value here at this level. You add it to a very small value here. Then you divide by 2. What do you think? You think the answer is going to be higher or smaller? Smaller. So I suspect that that curve is going to pass somewhere there. The same thing is going to happen here. It's going to be smaller. Maybe the curve is going to pass somewhere there. And when you come this side, similar thing. These two things are positive, just they are there. The value which was positive here and the big is now here, still big, and the one which was negative is still reflected there. Now these two graphs, they actually form a mirror image around y. Do you see that? So for this value there, I can take another value there. The value is going to be there. Come here, the value is going to be there. So this graph is more or less like this. And for your information, if you are maybe in town, I think in town you're also visible. If you look at the street lights or telephone lines, they are supported by masts or pillars like this. The lines are always going this way. Altogether, this curve which is made by the wire, the telephone cable, is actually described by cosh hyperbolic. So now you can see the application. Is it not interesting? It looks interesting to me. Because what do you do? You've got a reality, a physical object in the street, and you've got a mathematical expression for it in the mathematics textbook. Now you know where to apply it. All together? Okay. So now, yeah, at school, we started by adding. And after adding, what did we learn? After adding, immediately after learning how to add 2 plus 2, 4 plus 4, what did you learn to do? Subtract. So it's also interesting to look when we change this thing to e to the power of x minus e to the power minus x all over 2, average again. This function, I think you can tell me the name. After seeing the name of this one, you can tell me the name of this one. What do you think this is? This is called shine hyperbolic. People say shine, but you write it this way. Signage. Saying shine is just like a nickname of it, isn't it? Just for easy calling. Instead of saying shine hyperbolic, just say shine, as if this H was there. So don't confuse when you get that. So we've got two things there. Altogether, that is hyperbolic functions. Any questions that far? I think now it will be interesting, which I think for now, I'm going to leave it for you to engage with that, to try to play around with this expression, This is the expression of the function. This is just a name of the function, and the telling that the argument is what? Is x. Isn't it? So this is the expression of the function. So when you are evaluating the function, you are precisely using this expression. Like for example, let's see, what is the value of this function at 0? At 0. It will be 0 there, 0 there. What will be the answer? 1 minus 1. Isn't it? 1 minus 1, 0. Divided by 0, by 2, 0. So already it tells you that the function, this point is of that function. Isn't it? Then you can play around with the rest, then we see what happens. Are we together? Okay. Any questions that far? Ask questions, guys. Let's have questions. Now, can I give you 2 minutes or so? These are fractions, isn't it? Sorry. Close the textbook for now. The textbook, just throw it away for now. Yeah. Okay. Say this is a fraction and that is a fraction. Why I don't want people to look at the textbook when I'm teaching? I want us to focus on what we're talking about. Isn't it? The textbook can open it later. It doesn't go away. You will get. But what I'm saying is important. Maybe if you don't understand, you need to tell me. There, what do you mean? What do you mean? Altogether. So please, let's also focus on that. So these are fractions. This is like A over B. This is like C over D. Altogether. So what I want you to do, I want you to use your what? Your division of fractions. Divide these two things and tell me what you get. Divide them. Let's say I want you to say this one over that one. That's the first division. This one over that one. Do that calculation. Write this expression, divide this divided by that. So I instructed you to do division of sine hyperbolic or sine x over cos I need to know what that is. Give me the answer if you got it. Are you still busy? Who has finished? Let's see who has finished division. Okay. My sister, give me the denominator. Sorry? Give me the denominator. You check the other guys whether you agree. Give me the denominator. E to the power of x plus e to the power minus x. My brother, give me the numerator. E to the power x e to the power minus x. This is a new function. This function, we'll give it a name. If you think about this from school, this is suggesting the name of the function. What is the name of the function? Tan hyperbolic. Guys, let me just highlight something. Highlight something there. I'm trying to save you. I'm trying to make you find a way of remembering things very easily. As you can see, I'm associating these things with what you know. Altogether. So this is how sometimes you can use this strategy to learn. When you see something new you are learning, try to associate it with something which you already know. Then what happens? That it might be difficult to forget that thing because you are associated with something which is already sitting in your system. You know that's that. Altogether. Now, if you have got A over B, you invert that. If you invert, if I say invert, what are you going to get? You're going to get B over A, isn't it? So, invert this. Can you invert that and tell me what to write? Tell me what to write. What am I going to write? Cos. Let's forget about this one now. Let's just invert this. What am I going to write? E to x plus e to minus x over e to x minus e to minus x equals to, you can tell me yourself, isn't it? Good. So now if you forget it, remember you told me yourself, you gave the name to the function yourself. So, cot hyperbolic of x. Are you learning something? So today we've got new functions whose name, more or less, I don't know, what do you say, what's the English word for words which have got almost the same sound? No, synonym, same meaning, same sound. Homophones. Is it not homophones? What? I can't remember the... Earphones. That's very interesting. Okay, guys, so now we've got, maybe let's say the four first hyperbolic functions. And in this case, I can just invite you to look at everything which you know in trigonometry and try to find an associated function. Like if I say 1 over sine hyperbolic, see how it's going to look like and give it a name. You can do that very, very easily from what we have discussed now. So now, what can we say? We are in the presence of new functions called hyperbolic functions, and these functions are closely related to exponential functions, and also they are also closely related to logarithm functions. We're going to see that later. Otherwise, for now, I would say I've got the idea of hyperbolic function seated squarely in your head. Is that the case? Is that the case? Is that the case? I'm not hearing your answer. But if it's not the case, please ask. Is anyone got a problem? Anyone who wants to clarify something? Yes? The curve. The sketch of a curve, yes? For the sine hyperbolic. For the cos. Yes, what happened? No, I don't divide the upper. The function said add the two functions. I didn't say divide the upper. I said add the two functions. In other words, I've got a value. Let me draw a line here, vertical line here. I've got a value here for the decay. I've got a value there for the growth. I add them. What I'm going to get? I'm going to get a single number. This is what the expression is saying here. It said add these two functions. Once I've added, I divide by 2. My question was, look at that the values for the decay here are very small, and the values for the exponential growth are very big. So if I add them, the answer actually is not going to be very, very different from the upper one. Now if I divide by 2, is the answer going to be higher or lower? You said it's lower. Why that discussion? That discussion is trying to bring up where we can more or less imagine that the graph of the new function is. And our discussion led us to agreeing that the function must look more or less like this. Then I showed you the wire of the telephone line that is actually modeled using that kind of a function. Are we together? Thank you for that question. It was clarifying. I think maybe many people didn't understand, but I hope by now more information has been added. People can understand better. Another question. Are you telling me you're fine? Can I hear the answer? Are you fine? Okay. If you're fine, thank you for listening. Then let's proceed to the next step of our course.